Hello, if you are home on today's date, it's November 2nd and 3rd, and we are actually starting a little mini unit on ratios, unit rate, and unit price. So you may remember this topic from elementary school. We've got a couple questions to look at and then a little bit of practice for you to try. So number one says, Sally has 20 red dresses, 15 yellow dresses, and 15 blue dresses. Express the ratio of red dresses to total dresses in simplest form. All right, so you have to remember from elementary school, a ratio is a comparison of two quantities. So in this case, we're comparing red dresses, and it says 2, so that's another way to write a ratio, total dresses. So sometimes we could have done like red to blue, yellow to red. This time they're asking for red to total. So I want to go back and look at the problem. There are 20 red dresses, and then I need to find my total. So I need to go through. Total means we want to add. And I know 15 and 15 give me 30. So I'm really adding 30 and 20, which give me 50. And some of you might have already added that and known that it was 50. Now, I can't stop, though, because it says express the ratio, which I did write, but it just does say in simplest form. So I want to come back through and I want to reduce this. Now, some of you might notice there's a 0 at the end. I can reduce by 10 in my numerator and denominator, and I would end up with 2 over 5. Now, there's 3 ways to write a ratio. I could use the word 2. I can write it as a fraction, or I can use a colon. So those are just a little bit of review from elementary school about ratios. Number 2, a cookie recipe calls for 1 cup of sugar and 2 cups of flour. Which of the following mixtures will not follow the proportions of the recipe? So we're comparing sugar to flour. That's our ratio. And our fraction is 1 to 2, which I've already given us it just happens to be in simplest form. So let's look through and see which of the following will not follow the proportion. So they're looking for which one of these ingredient amounts, when I write them as a fraction, will not reduce to 1/2. So 6 over 12 does reduce to 1/2. So we know it can't be that one. I'm looking for one that does not reduce to 1/2. 4 over 8. Well, 4 is half of 8. That reduces to 1/2. 5 over 10. That reduces to 1/2. And you might have already looked and seen and said, I don't need you to reduce all these, Mrs. Carl. I can tell right away. 3 over 7 does not reduce to 1/2. So that would be our correct answer for number 2. Number 3, are the 2 ratios proportional? Now, you saw that word up here, proportion. Proportion just means 2 equivalent ratios, all right? So let's see if these 2 ratios are equivalent. There's 2 ways to check. The first way is I could just take my one fraction and reduce it and see if I get my other fraction. So 9 divided by 3 is 3. 12 divided by 3 is 4. I got the same fraction. That's one way to check and say yes. The other way to check if something is proportional is to do what's called cross multiplication or cross products. So I'm going to multiply 12 times 3, which is 36, and 9 times 4, which is 36. And because those are equal, it is a yes that it's proportional. You might remember calling this like the butterfly from elementary school. They have all different names for it, but it's called cross multiplication. Well, I'll say cross multiply. That's what that means. Let's take a look at our second one. 2 times 3 is 6. 6 times 1 is 6. So that's a yes, they are proportional. Those 2 ratios are equivalent. And let's take a look at our last one. Now, they're both improper fractions. So in this case, they have a good chance of being equal. 9 times 9 is 81. 12 times 7 is 84. Are these 2 equal? No, they are not equal. Those 2 ratios do not form a proportion. They're 2 great ratios, but they're just not equivalent. All right, so far we've talked about the word ratio, and there's 3 ways to write the ratio. And we've talked about the word proportion, and proportion is that's 2 equivalent ratios. And you can find that by reducing or by cross multiplying. Number 4, an art teacher mixes 40 ounces of yellow paint with 16 ounces of red paint. How many ounces of yellow paint would she need to mix with 36 ounces of red paint to maintain the same proportion? All right, that means we're looking for 2 equivalent ratios if we're talking about a proportion. So I'm going to start with what I'm given. I'm given yellow and red. So I've got 40 ounces of yellow and I've got 16 ounces of red. And then they said, how many ounces of yellow paint? So I'm going to need another ratio over here, but I don't know the yellow. That's what I need to find. Now notice I'm being very careful in labeling that my yellow is going to go on my numerator and my red is on my denominator. Would she need to mix with 36 ounces of red paint? So the red goes on the bottom. Okay, now there's two ways to do this. I can cross multiply. Okay, that's one way. Or I could reduce this fraction to start, because a lot of times over here, you might have even said, well, 4 times 3 is 12 and 3 times 3 is 9 and 3 times 2 is 6 and 1 times 2 is 2. That's another way, is just seeing what you're scaling up by. Well, 16 times 2 is not 36. But if I take this fraction and reduce it by maybe 4 or 8, I'm going to end up with 5 halves. Now, 2 goes into 36. 2 goes into 36 18 times, right? 5 times 18. And if you're not sure, you can always do it on the side or on your calculator. 8 times 5 is 40. Carry the 4. 5 times 1 is 5, plus 4 is 9. You'd end up with 90. So we're looking at 90 right now as an answer. Let's look at a couple different ways to also get 90. So I reduced my original ratio and then scaled up. That's one way. I could solve what's called this proportion by cross multiplying. So 40 times 36, and I'm using my calculator over here on the side. 40 times 36 is going to give me 1,440. So I know when I cross multiply this way, I have to get 1440. Now remember, the cross products have to be equal. So that means 16 times something has to give me 1,440. How am I going to figure that out? 16 times something has to give me 1,440. How could I find that number? Well, if you're not sure, think about what's the opposite or inverse of multiplying. That would be dividing. So we want to take 1,440 and divide by 16. And that gave us 90. We get the same answer both ways, okay? So a lot of kids will figure this out by process of elimination, guess and check. Some kids will even reduce this ratio and say 40 divided by 16 is 2.5, and then they'll multiply it by 36. Guess what that gives you? 90. So there's always lots of different ways to arrive at the answer. Just make sure that you can explain it and that you understand the process, so if you needed to replicate it somewhere else, you could. So that's more work on proportions. Let's take a look at number 5. A bean plant grew 12 feet in 4 days. After 10 days, the plant was 24 feet tall. Is the length of the bean plant proportional, there's that word again, to the number of days of growth? All right, you might be noticing that labels are kind of important here. In the last problem, we talked about yellow and red paint. We've talked about different colored dresses, sugar and flour. Today, we're talking about feet and days in this problem. So I'm going to make sure that I set up a ratio over here just of my words. So I know that when I put my 12 feet as a numerator, that's in the right place because I put feet on top. And days is 4 on the bottom. So that's the first part of my information. Then it says after 10 days. So where's 10 going to go? It's 10 days. It has to go on the bottom. The plant was 24 feet tall. So feet is on top. All right. We don't know if it's proportional yet. So now we need to find out if it is. Well, remember, we talked about lots of ways to do it. I see an obvious way here, though. 12 times 2 is 24. But 4 times 2 equals 8, not 10. So I'm going to say that's not equal. Now, maybe you wanted to do cross products. 12 times 10 is 120. 24 times 4 is 96. Those are not equal. So in this case, it says, is the length of the bean plant proportional to the number of days? We got no. All right, let's take a look at the back. So we're going to be moving into something called unit price and unit rate. So we've been talking about different ratios. When we move into a rate, the word rate is talking about two different quantities. And in this problem, we're talking about money and we're talking about ounces. So it's a ratio, just like it's a ratio like before where you can write it as a fraction, but it's going to have different units. This is money and ounces. Whereas before, on the front, we were talking about a red dress to a total dress. We're still talking about dresses. Okay. So it says Lisa and her sister are comparing the prices of 2 brands of cereal. Wegmans granola costs $3.15 for an 18-ounce box. Price Chopper granola costs $4.65 for a 38-ounce bag. Part A, what is the price per ounce of the Wegmans granola? Okay, so I'm going to go back and make sure this says the price per ounce. Whenever you see the word per, you're writing it as a fraction. So I want the price per ounce of the granola from Wegmans. So I'm going to make sure that I get the right information. Wegmans granola costs $3.15. My money I put on top, so I need to put the $3.15 on top. 18 ounces, that's going to go on the bottom because that's where I put ounces. Now in class, we talked about what does this fraction bar mean to do? Add, subtract, multiply, or divide. Hopefully you're remembering it means to divide. So we'd be plugging 3.15 into our calculator divided by 18. So $3.15 divided by 18 ounces. Now, my number is 0.175. Here's the issue. Money is not out to the thousands place, right? So I need to round. So I'm going to look to the right. The 5 tells me I need to round up. So this becomes 0.18. All right, the next part says, what is the difference in price per ounce? Okay, well, they're talking about Wegmans granola versus Price Chopper granola, right? So if I want to find the difference in price per ounce, I only found Wegmans so far. Difference means to subtract, if you remembered that. Well, I can't subtract if I don't have two numbers, right? I have to have at least two. So I need to find out what's the price per ounce for granola from Price Chopper. So I'm going to have my money per ounce again. It's $4.65. I'm going to put it on top because that's where I put my money, and 38 cents on the bottom. And remember, the fraction bar means to divide. So 4.65 divided by 38. So I'm going to plug that in, 4.65 divided by 38. And again, I've got a long number. I'm going to write maybe the first 3. I know it keeps going, but really, since we're rounding, we only need those 3. The 2 tells me to stay the same. Now, should I write 12 cents here? No. It says, what is the difference, right? So I've got one more step. I've got to take my Wegmans granola price and my Price Chopper granola price, and I've got to subtract them. Now, some kids will write an answer of 0.6. Really? It's a 60 cents difference? I don't know. I think we should subtract carefully. 8 minus 2 is 6. What's 1 minus 1? 0. So be really careful. That's why I left a space there. It's a 6 cents difference per ounce. So sometimes we'll talk about what one is the better buy. And because this one is less per ounce, this one is the better buy. So you'd say Price Chopper granola is the better buy. Might not be what you like taste-wise better, but it's the one that's cheaper per ounce. All right, let's take a look at number 7. Number 7 says the table below shows the prices of 3 different size packages containing the same type of candy. And we've got package A, B, C, we've got the weight, we've got the price, and then we want to know the price per ounce rounded to the hundredths. So price per ounce means money over ounce. So when I go to set my problem up, I've got to make sure I have money in the numerator, which is $1.70 for this particular brand of candy. And the weight they're telling me is 10. So $1.70 divided by 10. And that's going to give me, and some of you might have said, I can do that mentally. That's great. I'm glad you can. That gives me 17 cents per ounce. All right, let's take a look at package C. So this is like when you're trying to convince your parents to get you the bigger bag of candy because it's a better buy. This is the proof that proves why you should get the bigger bag of candy. We got money per ounce again, $2.10 over 15 ounces. And again, I'm hoping you're trying this with me at home on your calculator. The more you use it, the faster you'll get. If I plug in my money and divide by my ounces, I'm ending up with 14 cents per ounce. This is kind of nice. I don't have to round any of these numbers like before. And my last one, money per ounce, is $3.25 divided by 20. I'm writing it just horizontally this time just to show you that you can do it that way. It means the same as writing it vertically with a fraction bar. Oh, look at that. I spoke too soon. I got a whole bunch of decimals here. So what is that going to round to? If I look to the right of the 6, the 2 tells me to keep it the same. So just 0.16. Okay, now the question says, complete the table to determine which package has the lowest candy price per ounce. Well, Is 14 cents the cheapest, 16 cents per ounce the cheapest, or 17 cents per ounce the cheapest? Well, the best buy is the one that's cheapest per ounce, which is package B. All right, so we've talked about a couple things today. We've talked about rate, which is a comparison of two quantities. We talked about taking a rate and finding the unit rate, okay, which is per 1 ounce, per ounce. And we talked about better buy, which one is a better buy, which we talked about in the back. You're going to practice a few of these examples on a PowerPoint, and then you're going to do a Google form for a grade. So I hope you're having a great day. See you when you're in school.